Hello, in this video we're going to introduce integrals, which are also known as antiderivatives. This means that integrals are the opposite operation of the derivative. So let's imagine we have a function uppercase f of x and a function lowercase f of x. So if we go in this direction and to take the derivative, so this indicates that lowercase, if we take the derivative of uppercase f, we get lowercase f. But if we go in the opposite direction, we're gonna be we're gonna from the lowercase f, and to get to the uppercase f, we're gonna do the integral. So, which is also known as antiderivative. So this shows that we can go back and forth, between them. And from now on, we're just going to call them integrals, not antiderivatives. And let's look at some general notation for the integral. The symbol for the integral is this elongated s. Then you're going to have the function that you're going to be integrating. And we're going to have this term dx. In this case, is a dx because the variable that we are integrating about is x, and this is known as the variable of integration. Integration, in this case, it is x, but it can be t or y. So in another integrals, if we're integrating with respect to, let's say, t, you're going to have a dt instead of dx. And also, we have two types of integrals in the general sense. Those are indefinite integrals and definite integrals. The indefinite integral doesn't have any endpoints. So it is like as we see here. So when you take the integral of a function, you're going to get another function and a plus c. This plus c is a constant of integration. This is known as the constant of integration. So every time you do an indefinite integral, you're going to have a plus c. The other type of integral is the definite integral. In that case, we're going to have endpoints. So this means we're integrating from point A to point B. So I'm just going to point that out on the board, on the screen. This means we integrate from point A to point B. So for now, we're just going to be doing indefinite integrals. Later on in another video, we're going to be doing definite integrals. So, and let's look at some rules for integration. So the basic rule of integration is going to be the integral of a constant. So let's say we have a function which is a constant k. K is a constant, so the rule is very simple. So let's say we have the integral symbol of k, and with respect to x, we're integrating in terms of x. So in that case, we just have to place the constant k and the variable, and don't forget the plus c. And the plus c, as we saw in the previously, is the constant of integration. So this is the most basic rule of integration, the integral of a constant. Let's look at another rule. This is the second most basic rule, is the integral of a variable raised to a constant exponent. So let's say we have a function f of x, and f of x is gonna be equals to x to the nth power. So and n there's a condition on this one, and it is not equal to -1. So it can be any constant integer except for, or real number except for -1. And this rule is also simple. So let's say, so we have the integral, we have the integral symbol of x to the nth power. We have the variable of integration, dx, and the rule goes like this. So we're gonna have the same variable. Now the exponent is gonna be n plus 1. And then we're gonna have a denominator. So all this is all over n plus 1 as well. And don't forget the plus c for an indefinite integral. So this is the second most basic rule of integration. And let's look at some examples actually. So here we have an example. So solve the integral below. So in this case, we have the integral of kx dx. So in that case, it's simple. If you have a k, I'm just gonna define k. K is a constant. So if you have a constant, for example, 2, any number, we can just pull it out of the integral. So that is gonna be k integral of x dx. And we're gonna apply the rule that we just learned. So k and x. So x to the first power, so plus 1. So we have a 2 here. And we have to put a 2 in the denominator. And don't forget the plus c. So pretty simple, as we just did in the previous page. And let's continue with another example. Let's see what we have. And so once again, we can actually, I'm gonna, we can, if we have different terms in a function, we can actually split the integral in different terms. For example, in this case, we're gonna have 2x dx minus the integral of 3 dx. So, and let's do, so we're gonna do term by term just to make it simple. So I'm just gonna do step by step. So I pull out the 2, integral of x dx. And this for the second term, I pull out the 3, and we have the integral of dx. So in this case, we're gonna have x squared, oops, just put an n, x squared over 2. And for the second term, we're gonna have 3x. And don't forget the plus c. So we can clean up the first term a little bit, and we get x squared minus 3x plus c. And yeah, very simple. I just did it step by step, but once you get more comfortable with integrals, you can go from here to here in a single step. But I just broke it down so you can see every step. And has been everything for this video. I hope you understand a little bit better about integrals, and see you in the next one. Bye.